we should discuss a few ways that we can show molecules now, and these are, of course, through molecular models. And these will, of course, be used significantly throughout your textbook. It turns out that there's sort of an agreed-on color for individual atoms. Carbon atoms are usually pictured as black spheres, oxygen, usually red spheres, chlorine, usually green spheres. So when you see them in space-filling models, you'll just use the color to try to distinguish which atom they are. Okay, so if we want to show the exact ratio of atoms within a molecule, we'll show the molecular formula. So this would be methane, CH4. It shows us very clearly that there are 4 hydrogen atoms and 1 carbon atom in a methane molecule. Now, how does this molecule get put together? Okay, we can very easily think about several hundred ways to put this together. Is it 3 H's connected to the carbon and then 1 more additional hydrogen? It turns out that's not correct, and we'll see why shortly. But if we want to show the structural formula, or how these atoms are put together, what we're going to need to do is show the structural formula seen here. If we want to show some 3-dimensional structure to this molecule, if we just take a look at the structural formula, you might think that these hydrogen bonds are 90 degrees apart. But of course, we're just showing this structural formula in 2 dimensions. If we try to show information about it in 3 dimensions, we'll see that this takes on a tetrahedral geometry with an increased degree value of 109.5. We might want to show that information using a ball and stick model. Very convenient and very easy to show 3-dimensional information. Or, as we see ABC, we can also show space-filling model, and this is trying to show us some of the information about the electron cloud, where the electrons are at for associated with each individual atom. So here's the carbon atom and the 4 hydrogen atoms. So going through this, we can see that there's 1 blue sphere, that's nitrogen, 3 hydrogens, so of course that's NH3, or ammonia. It's a little bit harder to tell with these black spheres, but we can see that there's 2 carbon atoms, and then there's going to be 1, 2, 3 more hydrogens on each carbon atom. So this is going to be ethane, C2H6. And here we have a yellow sphere corresponding to sulfur, and then 3 oxygen atoms. So this is SO3, sulfur trioxide. So here's a few more examples of how we can display information about various molecules. One additional characteristic that we'll need to discuss is the empirical formula. So if you look at the molecular formula for benzene, it's C6H6. The empirical formula just shows the lowest whole number ratio. Since both atoms are divisible by 6, we can see that the empirical formula for benzene is CH, actually the same empirical formula as acetylene, C2H2. Okay, glucose, C6H12O6, is a simple sugar. It turns out that C6H12O6 can be the formula for a variety of different molecules. So, of course, if we want to show that this is glucose and nothing else, we might need to show the structural formula, the ball and stick model, or the space-filling molecule. I'll discuss this a little bit more in depth, but you'll see that we're trying to show covalent bonds as one single line that's sharing 2 electrons. If we have a double bond, 2 pairs of electrons being shared, we'll show 2 lines, and then 3 covalent bonds. A triple bond sharing 6 valence electrons will be shown as with 3 lines.